Hi class, in this video we are going to be introduced to polygons. Let's get started. The learning goal for this video is that you're going to learn about two-dimensional figures, polygons, and then you're going to classify them based on their different characteristics and properties. Before we talk about polygons, we're going to spend a minute talking about two-dimensional shapes versus three-dimensional shapes. So what exactly are dimensions? Well, to make it simple, dimensions are measurements. And the measurements that we use are length, width, height. For example, if you look at this simple blue line, it's a one-dimensional object because it only has length, not height or width. If we were to measure this line, we would just measure how long it is. A rectangle is an example of a two-dimensional shape because it has length and width. And a three-dimensional shape would be something like a cube because it has length, width, and height. So if we want to kind of look at the difference between two-dimensional versus three-dimensional shapes, this is what we can say. If we look at the two-dimensional shape on the left side, the square, it looks flat. 2D shapes are flat. When you only have two dimensions, that's how they look. Although many 3D objects and shapes are actually made out of two-dimensional shapes. Now let's look at the cube. Compared to the square, the cube actually has depth. It looks like it is coming out towards us a little bit. Sort of, that's why when we talk about like things like 3D movies or 3D effects, those are things that kind of pop out at you. So even though this isn't an actual cube, it's just a picture of a cube, it actually looks like it's sticking out compared to the square. Again, it has three dimensions. It has the length, the width, and the height. And if you look at the cube, each side of the cube is actually made out of squares, right? So the sides of the cube, the faces of the cube, are actually made out of 2D shapes. When you combine those 6 squares and put them together, you get a cube. Now, let's refocus on polygons. As we just learned about two-dimensional and three-dimensional shapes, polygons are 2D shapes. And here are some examples of what polygons might look like. A little bit of a history lesson. The word polygon was actually created by the ancient Greeks. And the word poly means many, gon means sides. So polygon means a shape that has many sides. Today, we're going to learn how to classify polygons. And to classify something means to put it in a category. It's very similar to comparing and contrasting when we look at when we compare two objects and go, what do these things have that are similar? What's the same? What's different? That's sort of what we're going to do today with polygons. We're going to look at them and we're going to categorize them according to different things. And here's a quick example of what it means to classify. You can see right here, I have an apple, I have an orange, and I have a playground ball. And we can classify these in many different ways. There are many different categories we could put these objects into. Here are just a few, for example. We could classify them. Okay, the apple and the orange are fruit. The playground ball is not fruit. The apple and the orange both have seeds. The playground ball does not have seeds. So that's another type of category. The apple and the orange don't bounce. The playground ball bounces. The apple and the ball are both red, so now I'm classifying or categorizing these by color, and the orange is orange. Here's a category where they're all the same. All of these objects are round. So again, when we classify, we are going to put things we're going to look at different things, and we're going to look at the different properties or characteristics that they have, and we're going to use those categories and characteristics to try and describe them. So again, I describe these objects. These are all round, okay, and so on. Polygons are classified in three ways. We classify them by how many sides they have, by how many angles they have, and then we also classify them on regularity. And the first thing we're going to talk about is we're going to talk about sides and angles. And I'm going to do that by introducing you to a lot of different polygons. Some of them you might have heard of before. Some of them might be brand new. But again, we'll talk about sides and angles first, then we'll talk about regularity. So are you ready? It's time to finally meet some polygons. And our first one is the triangle, which should be a familiar shape. And a triangle, it has three sides, it has three angles, and it has three vertices. And a vertice is where it's a corner. And I'll show you some vertices. I'll kind of explain that in a minute. The prefix of the word triangle, tri means three. That's why a tricycle has three wheels. That's why a tripod, that a lot of people sometimes put cameras on, a tripod has three legs. So tri means three. And here are the vertices. If you see those black dots, those are the corners. A vertice is any point where two lines are touching and making an edge or a corner. It's called a vertice. If we're talking about one of them right there, it's called a vertex. So if I'm talking about just one, the singular form of it is vertex. But if I want to make it plural and I want to talk about all of them at once, if I'm talking about one, I say vertex. But if I'm talking about all of them, I say vertices. So a triangle has three sides, three angles, three vertices. After triangle, we have quadrilateral. And a quadrilateral has four sides, four angles, and four vertices. And that prefix in the front, quad, means four. And here are the vertices. Again, the vertices are the corners where where two lines are touching and making that edge. And why do you think four-wheelers are called quads? Ouch. After quadrilateral, we have pentagon. And a pentagon has five sides, five angles, five vertices. And that prefix, penta, stands for five. Here are the vertices. And after this slide, I'm not going to show the vertices anymore because it's a pain to do them on all of the shapes. So I did them for these first few ones so you could kind of get the idea. But after this, I'm just hoping that you understand that they're the corners. And here's a real world example of a pentagon. The nickname for the United States military headquarters is the Pentagon. Can you see why? After pentagon, we have hexagon. And hexa means six. Six sides, six angles, six vertices. Moving on. After hexagon, we have heptagon. And hepta means seven. Seven sides, seven angles, seven vertices. So hepta means seven. That's another Greek word. So in Greek, hepta means seven, gon means sides, seven sides. And then after heptagon, we have another familiar polygon that many of us have probably seen before in the real world, an octagon. And octa stands for 8 sides, 8 angles, 8 vertices, And an example of this might be, some of you might know that an octopus has 8 tentacles. So you might already kind of know what octa meant. Here's some other examples of octagons that you see out in the real world. A stop sign is an octagon. And then if you've ever heard of UFC, Ultimate Fighting, the fights happen in an octagon, which that's kind of what they call it. Instead of, like, I don't know, in boxing, they call it a boxing ring, even though it's not a ring. But in UFC, when they say their fighters are going to fight in the octagon, it's an actual octagon. After octagon, we have a nonagon. And nonagon stands for 9 sides, 9 angles, 9 vertices. So moving on, we have a few more. After nonagon, we have a decagon. And deca represents 10 sides, 10 angles, 10 vertices. After decagon, kind of an unusual name, we have a hendecagon. And a hendecagon, as you can probably guess, has 11 sides, 11 angles, and 11 vertices. It represents 11. And then after hendecagon, we have a dodecagon, which is where that's as far as we're going to go for 5th grade. That's as far as a lot of people go. Dodecagon, 12 sides, 12 angles, 12 vertices. And that stands for 12. But just for fun, just because I really think this is kind of interesting. Let's skip to 100. We went up to 12. Let's jump all the way to 100. Yep, the Greeks actually have names for all these polygons. So can you guess what a polygon with 100 sides, angles, and vertices is called? Take a guess. It's actually called a hectogon, and that's what it looks like. That is actually 100 lines all connected together. It's got 100 sides, 100 angles, 100 vertices. And you might actually be thinking, hey, isn't that just a circle? It's very close to a circle. It's not a perfect circle. And something else you might have noticed as the polygons kept adding, as the sides went up, the angles went up, the vertices, as those numbers kept getting, the polygons looked smoother and smoother. This one looks very smooth compared to, if we jump back and we looked at a nonagon, right? This looks very smooth, which actually brings me to something that I think is fairly interesting that I'd like to share. If you like video games, if you like to play games, 3D graphics are made out of polygons, usually triangles. So if you want to look at this picture here, this is a picture of, I think, maybe Beethoven or Mozart, not sure. But if you look on the left, somebody tried to make that statue and they were only used 60 triangles, 60 polygons. And with only 60 polygons, it wasn't very detailed. Then they have a version of it with 600 triangles. It has 100 times the triangles as the first one. And you can actually kind of see the shape of the face and the hair, and you can kind of see it's a statue. And then if we go 100 times bigger than that, and we jump up to 6,000 triangles, look how much smoother it gets. And look how much more detailed it gets. And then finally, all the way on the right, the final statue, it's made with 60,000 triangles. And another picture I'd like to show to you, just because I like video games and I think it's interesting, is if you look over here on the left, that it's got a timeline. So in 1999, that character was made with 350 triangles. 350 polygons were used to create that character. You move up 6 years, so like 1999, we're thinking like that's around when PlayStation 1 was around. That's kind of when I was, I had a PlayStation 1 in 1999. 2005, that's PlayStation 2, original Xbox. And now we've got a character made out of 1,500 triangles. So many more triangles, and look at the difference between how much more detailed that is compared to the first. Then we jump up to 2010, 15,000 triangles. That's kind of like Xbox One, or not Xbox One, Xbox 360 and PlayStation 3. And then you come up to 2012, and that's when you get PlayStation 4, Xbox One, 20,000 triangles. And now we're at the point with, next gen consoles about to come out like PlayStation 5 and Xbox One X, 100,000 triangles. And look at the difference from that, the graphics all the way on the right compared to all the way on the left. And that's just what happens when you can add more triangles. It's sort of like how that Hectogon looked really smooth. The more you add, the smoother it gets. The problem is with the older video game consoles like a PlayStation 1, it just wasn't powerful enough to show that many triangles at once. Computers weren't very advanced back then compared to today. Now we have processors that can handle showing that many triangles and objects on the screen at one time. So that's how computer graphics have evolved. Now you know. Moving on. Now we're going to talk about regularity. So we're going to talk about regular polygons versus not regular or irregular polygons. And first thing is, I'm going to throw another new word at you. You've got a ton of vocabulary thrown at you in this video so far. We've talked about dimensions. We've talked about what polygon means. We've talked about all the prefixes. We've talked about tri, quad, penta, hexa, hepta, and so on. We've talked about what the word classify means. And now I'm throwing congruent at you. And congruent means equal, same, identical. So if you look at this pentagon here on the screen, this is an example of congruent. All the sides of the pentagon are equal. And if you see those little dash marks going through each line, let me actually show that to you real quick. Let me show one. These lines right here. See how each side has one of these lines in it? That's a way to show if something is congruent. Since all of these sides have that one line through the middle, that's a way of looking at it and saying, hey, this side is the same as this side, this same is the same as this side, and so on. So all the sides are congruent and all of the angles are congruent. I could have paused the video to erase, but I didn't. I forgot I could do that. So sorry. So this pentagon has congruent sides and angles. And a polygon that has congruent sides and angles is called a regular polygon. So that pentagon that we just looked at, let me move back to it. That is a regular pentagon. It has congruent sides and angles. Here's some other examples of regular polygons. You have a regular hexagon on the left. All sides are equal. It shows us the measurement of all the angles. They're all 120 degrees. We have a regular octagon. We have a regular quadrilateral or a square. And then we have a regular triangle. All of them have the same angles. They all match. All the sides are the same. Now, the opposite of a regular polygon is called an irregular or a non-regular polygon. And those polygons, if it's irregular, nothing is congruent. The sides aren't congruent, or the angles aren't congruent, or both. So if you look at these three examples here, it's pretty easy to tell that the sides aren't the same, the angles are all different, and irregular polygons usually look kind of funky like this compared to a regular one. A great example of an irregular polygon that you might see in the real world if you're a baseball fan is take a look at the home plate in baseball. Not all sides and angles on the home plate are congruent. What polygon is a home plate? What polygon is that? Yep, it is a pentagon. It has 5 sides, but it is not a regular pentagon. It is an irregular pentagon. And here are some more examples of regular and irregular polygons. So if you look at the left, you can see the regular version, and then you can see the irregular version. So again, if you look at the triangle, You compare the triangles, you compare the quadrilateral and the pentagon, the hexagon, the octagon. You can kind of see, if you look at the irregular ones, you can tell they just don't look quite the same. You can tell that not all the sides are the same. And that since not all the sides are the same, it's also the angles aren't also the same. On the regular one, you can see all the sides are the same length and all the angles are going to be the same since all the sides match. Which one of these is the irregular polygon? Which number? It was number 3. Can you tell what shape? What can you name what polygon is number 3? What is it called? It has 6 sides, so it is an irregular hexagon. Okay, before we end this video, we need to go back and revisit the learning goal. At the beginning of the video, I shared this same slide with you, and I said our goal was to learn about two-dimensional figures or polygons, and we're going to classify them based on their properties. So let's recap and reflect. Polygons are two-dimensional shapes. Polygon means many sides. We classify polygons by their sides, their angles, and their regularity. The name of a polygon tells us how many sides, angles, and vertices it has. And if a polygon has congruent sides and angles, we would classify it as a regular polygon. And if a polygon has incongruent sides and angles, then we would classify that as an irregular or non-regular polygon. So if you just look at this slide real quick, look at all the words that I highlighted. These are all kind of new vocabulary words for us that we have to learn. We have to know what classified means. We have to know what angles are. We need to know what vertices means. We need to know what congruent means. We have to know what polygon means. We need to know the difference between a regular polygon and an irregular polygon. We have to know what all those prefixes mean. What does tri mean? What does deca mean? What does octa mean? What does hexa mean? And so we have to learn all of those things. So if you need to go back and rewind the video, maybe write down some notes, maybe draw some pictures in your notebook, I would recommend you do that. That's really going to help you learn all of this. All right. So we're kind of at the end of the video. Thanks for watching, and I'll see you again on the next one.